it's a mystery, right? I mean, for instance, some of the materials that we've measured have anomalous isotope ratios. Okay, so the isotopes for in one of these examples, and the data has to be reproduced by others, has incorrect magnesium isotope ratios. So magnesium has three isotopes, 24, 25, and 26. 24 is about 80%, and then it's like 11 and 9%, or 9 and 11 for 25 and 26. And that's what you'll find pretty much anywhere on Earth. It's pretty much what you'll find on Mars if you were to go and collect magnesium on Mars. And if you go out to the Oort cloud, it would be pretty much about the same ratios. So the ratios of one of these samples that we got from an unusual observation of an object is something like 60%, 20%, and 10%. Completely off normal. So that's not proof of anything, right? That's just data. So you have to ask the question, okay, well, who would change the ratios, right? Because if you make the assumption, and it's an assumption, that there's nothing in our immediate solar system that should have such anomalous ratios, okay, so that means it was probably made somehow by somebody. Why would you do that? The question is not so much, did it happen? The question that's more important is, why would you do it?
In this podcast, I'm sharing my passion and curiosity for soft robotics, where we share inspiring stories about the work we do and how we can push the limit. I am Mara Dwiney, and this is Soft Robotics Podcast. Support for this show comes from Science Robotics Journal. I really find Science Robotics to be a great resource for reliable and tangible research where we can really push the limit of the science we do in robotics. Great way to stay up to date with the published article is checking out the released monthly issue. All the links will be included in each episode description. We will also happen to have a regular conversation on the most published science robotic articles, where also you can contribute with your question and thoughts about the research. Thanks Science Robotics for sponsoring Soft Robotics Podcast. What gives you interest in testing material from UAP crashes? Can you tell us more the story and interest here to do that?
Right. So I got interested actually a long time ago, about a decade, when there was a report that basically on the internet and YouTube's about a small mummy that people thought was an alien, right? Because the mummy looked very unusual. It was only very small. And I thought, well, gee, I could do the genetics of this and determine whether or not it is something else, or whether it's human, or actually at the time I thought it was the mummy of some kind of a monkey. Uh, we eventually published a paper showing that in fact it was a just a human with it was an unfortunate, probably a preterm birth that somebody had mistakenly identified as an alien. And we published a paper on it, showed that the genetics of it was such that it likely had a number of mutations that caused bone deformities, which is what caused it to look the way that it did. Uh, the UFO community didn't like that, primarily because I was pulling the rug out from underneath the claims of a number of individuals. But to me, it wasn't about proving or disproving one way or the other. It was just getting the data out there and getting good science done. And that eventually then brought me to the attention of people in the government who wanted then for me to help them study individuals who they had claimed had gotten close to a supposed craft. This is all alleged. I wasn't there. I'm only the person doing the testing. And they asked me to do and help them with analysis of some of these individuals. If you look at who these individuals were, they were all either intelligence personnel, or they were Department of Defense people in aircraft pilots, etc. And some of these individuals were actually related to what you might know of as the Nimitz aircraft event, where the pilots had seen anomalous aircraft capable of doing things that supposedly we currently cannot do. And that was kind of my introduction to it. Then they started saying, okay, well, gee, you can do these other studies on the people and their blood and the MRIs that we've done, but we also have these materials that supposedly some of these craft had left behind. What would you do with them if we gave you some of them or we asked you to help with some of them? And then, so the first thing I said was, well, we're just going to go and we're going to do straightforward materials research science with these. They're metals, they're straightforward ways to study these things. So I had some of these instruments in my lab. These are various kinds of mass spectrometers that could determine both the elemental as well as the isotopic constituencies of these things. So we did that. We published a paper. My push has always been that you don't do science through press release. You do science through peer review. You wait until the peer review is done, and then you publish the paper. And when the paper's published, then you start talking about it, because that's how the right way that you should be doing science is.
I want to ask you first, before going to the material part, were you afraid to do that at the first class? That's terrified or afraid. For example, when we have Avilob, he has like a painful experiences. Sometimes people, skeptics, and you know already that there's a lot of shame sometimes to talk about these topics. For you, the decision to do that, were you afraid or skeptical?
I
Or
wasn't I wasn't afraid per se. I was afraid of what some of my colleagues might think of me for doing it. But the way I argued back with them when they brought it up, I mean, one of them directly told me, Gary, you're going to ruin your career talking about this, was I said, I'm not coming to any conclusions. I'm just trying to convince you that the data is real. You can't argue that the data as collected is real. You can only argue about the interpretation of the data, right? If you make the wrong interpretation, you can be made to look like a fool. But if you basically only say, here are a number of hypotheses that might explain the data, but I haven't proven them yet, but I will convince you that the data has been collected correctly, you help me interpret it. You can't argue with me about that. I mean, what scientist takes a possible explanation off the table, right? If nothing has been proven or disproven yet, what scientist throws away data which is absolutely real? Again, it's a subtle distinction, and a lot of the people in the public think that data collection equals conclusion. It does not. It's all about the collection of the data and then getting people to help you interpret it, because it's a mystery, right? I mean, for instance, some of the materials that we've measured have anomalous isotope ratios. Okay, so the isotopes for in one of these examples, and the data has to be reproduced by others, has incorrect magnesium isotope ratios. So magnesium has three isotopes, 24, 25, and 26. 24 is about 80%, and then it's like 11 and 9%, or 9 and 11 for 25 and 26. And that's what you'll find pretty much anywhere on Earth. It's pretty much what you'll find on Mars if you were to go and collect magnesium on Mars. And if you go out to the Oort cloud, it would be pretty much about the same ratios. So the ratios of one of these samples that we got from an unusual observation of an object is something like 60%, 20%, and 10%, right? Or 16%, adding up to 100. Completely off normal. So that's not proof of anything, right? That's just data. So you have to ask the question, okay, well, who would change the ratios, right? Because if you make the assumption, and it's an assumption, that there's nothing in our immediate solar system that should have such anomalous ratios, okay, so that means it was probably made somehow by somebody. Why would you do that? So the only thing that humans use isotopes for these days is either to blow things up as tracers in the body, or to use it to kill cancer. And sometimes isotope ratios are used now in money to embed isotopes, stable isotopes, in money as a signature for anti-counterfeiting, right? So that's the only things that humans do it for. We don't quite understand why you would change the isotope ratios for magnesium. There's no industrial purpose. So it's not just, the question is not so much did it happen? The question that's more important is why would you do it, right? Why would you change it? Or maybe it's that somebody didn't purposefully change it, but perhaps, and this is perhaps a good thing for your audience to think about, and I'm more than happy to receive emails on this, is what industrial process would create this such that it would be, these isotope ratios would be downstream of some upstream process. Now, the people in the government with whom I've been talking about, again, speculation, is, well, maybe this is downstream of a propulsion process that something is using, and that these ratios are changed from normal magnesium ratios to these altered ratios. I don't know. I just find it fascinating. I mean, who couldn't be interested in something like this? If it's done, I do it in my spare time, to be quite honest. It's not the primary function of my lab.
But maybe going to the sample itself, the material, because I think maybe we'll, even though just asking about the origin of the samples or the collected samples, and how to make sure they are really from unidentified flying objects or whatever. For you, you don't care about who's doing that, but you wanted the data. But how to make sure the samples are really related to something, maybe, as you say, exotic.
So, I get lots of emails, and the people with whom I work, of course, get lots of uh, uh, offerings from people of stuff that supposedly came from an object. So much of the work that we do is things that we have a good sense of the propriety of it, right? That the object had multiple witnesses. People got to the material as soon as possible, and that there was a chain of custody. I mean, at the end of the day, you can only trust the people involved, and you usually look to see, well, are these people asking for money for this? And if they're asking for money, that is a big red flag, and we usually put those kinds of samples at the end of the list, right? If they personally have no monetary gain to make from it, and if anything, they don't even want their names released, that's usually a positive, right? Because they're just saying, hey, this fell in my backyard, and or I saw this happen. In the case of the magnesium, it happened actually in Brazil, Ubatuba, Brazil. It was a fisherman. He saw this glowing object, and then it released something that basically exploded. And he picked up some of this material, and he went to some scientists that he knew and said, "What is this? This is what I saw." And that's all you know. In the case of the paper that we published, we actually published a paper, a peer-reviewed paper in Progress in Aeronautics, Aeronautical Sciences. And it was peer-reviewed, took 2 years to go through the peer review. And it was another one that actually happened in an area called Council Bluffs, Iowa. And there were probably about 6 or 7 simultaneous witnesses, saw an object, saw it release something, and they actually thought it was an airplane crash. And so everybody rushed to the place where they saw it drop, which was in the middle of a park, and they found a pool of molten metal. And they collected it. The police came, they took pictures of it. I have the original Polaroids from this. This was circa mid 1970s. And so we did the analysis of it. There's nothing actually in that one unusual about it, except that we looked at multiple samples, subsamples from the original sample, and each one was different in terms of the elements that were in it, right? So there were things like titanium and iron and chromium and a few other things. And It wasn't that the isotopes were different. It's just that the ratios of the elements were different, which means that whatever it was incompletely mixed, right? It was not homogeneous. It wasn't like somebody put a smoothie in a blender, and mixed it all up. It was only partially mixed and then dropped. And so that's another kind of mystery. Who would, let's say it were conventional, who would drop 30 pounds of molten, incompletely melted material in the middle of nowhere from a hovering object? I don't know, but it's interesting. I've been contacted by a person here in California who had a similar thing happen on his property that his mother had observed. And I was just speaking with him yesterday, where there's an object and it just releases molten metal. And he's sending me some of the molten metals. So there's actually probably, I know of about half a dozen stories like that. And so, let's call it a hobby. I'm collecting the information. I'm creating a catalog of what it is that we're observing. I'll at some point put the ones that are more interesting, I'll get them published. And, at a certain point, no one's going to want to publish this stuff anymore because it starts to become repetitive. We'll just create a database and perhaps publish a review paper that says, here's all the things that we found. You tell me what it is. Now, that's just my personal interest. But now you have the U.S. government and the Department of Defense has passed a bill that some of your listeners might be aware of. The Department of Defense bill now officially has created an office which is to collect this kind of information from all across the U.S. services, observations, materials. There's now money that's coming to the table. I'll be applying for some of this money to help me pay for some of the analyses that we're doing, because the analysis actually is expensive. I've done all of it so far out of my own pocket, and it's probably cost me about $70,000 to do this analysis. So it's not a small amount. I'm not, filthy rich or anything, but I felt it was fun and something to do. But having done it and published it, and being willing to talk about it has, in a positive way, brought me to the attention of people in the government who do think that this is important. And they've said, well, look, you're willing to do it. You're not afraid. And you seem to be able to talk about it respectfully. Why don't you come and help us? And since the paper has been published and other things have happened, I now have students at Stanford and at Harvard and other places in between who said, hey, we find this interesting. We're willing to help. So the objective has been met. And Avi is doing the same thing. Avi Loeb is doing the same thing. The objective has been met. Talk about it in a credible way, in a respectful way. Don't demean the people who claim that it's extraterrestrials, and don't demean the people who claim otherwise. Just say, let's collect the data. But it brings in people who are open-minded enough who can perhaps contribute. Because let's say it is something not from this earth. What can we learn from these materials? Maybe it's just, as I've said in a couple of other interviews, maybe this is just a form of exhaust, a leftover from a process of propulsion or energy generation that these things might use. What can we learn from that? What does it tell us about the engine by studying these things? I find that fascinating, because if they can move the way that they're moving, it's doing things that we don't know how to do, which means that there's an understanding of physics that they have that we don't. Wouldn't that be fascinating to understand?
But maybe I'm curious about what kind of tests you did in these materials. You mentioned there's something maybe exotic or maybe never made before, but what other maybe characteristic shows the test you have noticed and you think that was very maybe peculiar? Because you mentioned, I don't know, there are many possibilities here, but maybe from the tests you did, what kind of interesting or something peculiar from the tests you did, besides what you noticed?
Well, so the isotope ratios are probably the most interesting one, right? Because the time that the magnesium sample was found, it would have cost a lot of money for somebody to change the isotope ratios by conventional means. You can do it either by a form of centrifugation, you can do it by a form of gas phase separation. For instance, the centrifuges that people use to make uranium isotopes, right? I mean, those are expensive to run. Uh, you can go online, people who are interested, there's companies that sell some of these isotopes, and they sell them in milligram quantities, and they cost tens of thousands of dollars to get the purified isotopes. So, uh, some of the stuff we have it in the pounds. So if you look at the cost it would take, it's in the many millions of dollars. It's not something you blow up on a beach in Brazil and just let it spew all over the beachside and the water, right? So that I find interesting. There's another material that somebody, and I have some pieces of it. Um, there's another material that's interesting. It's a bismuth magnesium layered. Clearly, it's industrial, and it's layered in a way that is at the a few nanometers per layer. Um, some people claim that it might be a waveguide, a metamaterial waveguide. That's not something when this was found that we had the ability to make. So the open question is it was it manufactured, or as some people have claimed, maybe it's just a byproduct of standard smelting, and somebody found it from the bottom of a smelting pot, right? So I don't know, but I've looked at the material. It is layered in an interesting way, and each of the layers is individually made of a different element. That doesn't sound like something you find in a smelting pot, right? No matter how well you tune your smelting. So again, it's I don't know what these things are, but now that the office is funded, basically, I'm hoping to gain access to some of the other materials that are claimed to be owned within the government, to take a look at it. Now, interestingly, it's not just the U.S. government that has these things, right? There's actually some stories coming out of China that the Chinese, um, some of the Chinese aircraft carriers are seeing the same thing. There's stories coming out of Russia. There's a very good story two stories out of both India and Iran about things that have been seen. So again, seen by the air forces of those respective countries. So it's not America centric. I know France, for instance, has a very big program on the study of these things. It's a government funded program. So although everybody thinks that it's all about America, it's not. This is worldwide. These things are seen. Again, what they are, I don't know. But as Avi Loeb has said, let's collect the data. Right. It's what I've been saying for the last many years, and then if we can bring the right kinds of minds to the study of this, either we'll prove that it's just something natural and it's not something from out there, or if it is, I mean, it's a bit of a Las Vegas bet. But if it is something from out there, why wouldn't we want to know this, right? And to know, perhaps in a different way, we are not alone.
Mm-hmm. That's a very interesting point. But maybe I'm curious to ask you, because one of the questions from the audience about this puzzle and the material is not the full picture, the whole materials or the whole samples. I don't know what kind of percentage that you have this kind of access to these samples and to make this full story, because now you just have the testers and this is something peculiar, but you mentioned you still also need to access more samples or other. So,
Yeah, yeah, there are more. I mean, eh, all we're getting right now, and this is, of course, I mean, I think the questioner, the person asking the question is right, is we're getting only a small piece of the picture. And if I'm getting only a small piece of an object, I wonder what it is that I've been given, right? And if I'm being fed something on purpose, which is wrong, a hoax. A person in the intelligence agency once told me, he said, Gary, when a scientist gets 95% of the answer, they think they can publish. In the intelligence services, when we get 95% of the answer, we feel that somebody has given it to us. We are interested in the 5% we don't know. That's a different mindset, and I think that's the mindset of the person asking the question, which is the right way to ask it, is what don't we know, even though we think we have something interesting. So, but that is my question. I want to know more about it. I think I've got a piece of the puzzle, but there are other objects supposedly that have more story behind them. I would like to get a hold of something which is not historical. I would like to get something which is contemporaneous, something which has happened recently, something where the story is new, the object we can get access to almost immediately so that there's no question, bring all of the forensic resources of materials analysis to the story to understand it, right? But it's interestingly not just about the objects that we get, the observations of what some of these things can do. So, for instance, the USS Nimitz objects, that the so-called Tic Tacs that went from sea level to space in less than a second. So, a physicist calculated the amount of energy it would require for, let's say, a 1-ton object. Let's estimate that the thing was about 1 ton. Let's say that the object was about 1 ton. The energy required to make that movement is like more than the nuclear energy output of the United States for a whole year. And yet these things were making those kinds of movements every few seconds. So either it's a projection, a holographic projection of something, and it's not really an object. It's a pretty darn good looking projection. Or it's an object that has access to energy or a means of propulsion that we don't understand, that doesn't need that kind of energy, but it knows how to do it without conventional physics explanations. So, and yet these are objects that were seen not just by the pilots, they were seen by multiple radar systems for multiple different ships at the same time. So that's another kind of evidence that then you have to ask, okay, well, if they can do it, how are they doing it? So, in a way, these are like, it's almost like an intelligence test. You can look at it and say, oh, I can dismiss it. I don't understand it. It can't possibly be, so therefore I'm just not going to think about it at all. That would be a stupid thing to do, in my opinion. Or you can look at it and say, this is a clue. This is a kind of physics that maybe we can do. I mean, when humans watched birds fly, from thousands of years ago, they said, we want to fly too. How can we do it? And eventually we figured out how to. So if we can see these objects, whether they're natural phenomenon, whether they're some other civilization or what have you, it's almost like the term, laying of breadcrumbs. Somebody is showing us something. Something is showing us a possibility that maybe we can think about how to access. And when you think about this, I mean, there's a physicist by the name of Alcubierre. Some of your readers might and listeners might know of Alcubierre. He's a Mexican physicist who came up with a way to manipulate Einstein's equations to create a so-called warp bubble, right? And this warp bubble could allow us to potentially fly faster than light or travel faster than light. I mean, there's a serious limitation. The amount of energy that's required to accomplish what he thinks he wants to do is well beyond human means to undertake. But that serious possibility has led to an entire field of physics, serious physicists, not crackpots, to say, well, actually, Dr. Alcubierre, you don't need as much energy as your first equations required. We can change these terms, and actually we can use 1,000-fold less energy to accomplish the same thing. So, whether anybody eventually creates a faster than light drive is less important as the physics and the thinking process that it uh, creates in the individuals and physicists to come up with ways to accomplish it in the long run. It's like a word game. It's a test of your creativity, and I think that that's a positive thing.
Mm-hmm. I'm going to ask you the correlation, maybe the material you're testing and the tic-tac that would have been shown in 2015. Do you think the material you testing and what we saw in the video was very, sometimes it sounds scary, what the thing that can do this behavior, as you mentioned and illustrated. Do you see any correlation between the material and the tic-tac, for example, that we saw in 2015? Do you think something here you can connect the dots between the material and how something that can do something we can understand, or at least we have never encountered something like that? Do you think any correlation between the material and this structure of this object?
Okay, so I am a big reader of science fiction, right? So a lot of people have spent a lot of time thinking and coming up with fun ideas about how the universe might be structured and who might be in it. If I were to speculate from a science fiction standpoint, I might say that the materials that we see ejected are a form of exhaust from an engine that has said, I don't need this anymore. I've used it. I've used it for what it's good for. I'm going to get rid of it. It's kind of maybe think of it as a fuel. The fuel starts as one form and then it gets manipulated by some process we don't understand. And when they're done with it, it gets ejected. Just like we do with a car, right? We have fuel, gasoline. It gets ejected in the form of hydrocarbons and water if you have a good catalytic converter. So we don't care about spewing this into our atmosphere. Maybe these things don't care about offloading a little bit of metal every once in a while, as long as they're not dropping it on somebody's head. Right? So that's a correlation that I see. The other material that I'm aware of is that structured one. There's physicists who are, they're serious physicists, but I think mainstream physicists would consider them fringe, that say these are waveguides, right? That this is a way that you can structure electromagnetic impulses, and this is a great thing for your audience to think about. These metamaterials are somehow structuring things that allow you to alter gravity. I don't know, right? I mean, there's metamaterials that developed up at Berkeley nearby that can make things appear invisible to certain wavelengths. I mean, this is reality. It's published in Nature and Science. There's ways you can alter at least wavelengths to make things appear to certain frequencies invisible. I think we're at the only very beginning of our understanding of what physics really is. That there's really a lot more to be understood about how you can compose materials to accomplish novel functions. And again, your audience is very well aware of the kinds of things that you can do at the nanomaterials level. You put an atom of this here, an atom of that there, an atom of that there, and now you have a qubit, right, for quantum processing. You put different kinds of atoms together in different ways, and you can get exotic particles in materials. You can get plasmons and all kinds of other things that can be used in ways that 20, 30 years ago would have been thought impossible. So, I think that what I look at, say, for instance, these isotopes, and I say, well, perhaps we haven't fully understood what the various isotopes of a given element can do that are different one from another. I mean, here's an interesting one. So lithium, right, has two isotopes. And lithium is used, standard lithium is used as a, in basically psychiatry and psychology for people who have certain kinds of mental disorders. And lithium is used to stabilize these people. I happen to know this because one of my aunts was on lithium. She had a disorder. So I think the lithium ratios, I forget, so let's say they're 60-40. So they did a study with rats, and they used the two different ratios. They purified them, and they gave them lithium, one of the isotopes, and lithium the other isotope. And this was done to nursing mothers of rats. I don't remember the exact study and why they did it, but what they found was that nursing rats would, if they were given one of the isotopes, would overfeed the pups and over, pay attention to them. And the other isotope, they would completely ignore the pups. That's interesting. So biologically, something in the brain bound those two isotopes differently. So they're not the same, even though most chemists think of isotopes as being the same. We talk about them as the same. But the natural ratio was just right, kind of like the Goldilocks, right in the middle. But the two extremes would give you very different and actually pathologic results. So, there's good reason to think that chemistry could take, or physics could take advantage of novel kinds of isotopes in very useful ways. Another example of this is silicon. There are certain ways that you can make silicon-based qubits that some of the isotopes, one of the isotopes of silicon, is much, much better and will hold its quantum distinctiveness longer with one of the isotopes of silicon versus another. And that's published, right? That's not just something somebody talked about. So there's what I hope this does, these kinds of results do, is make people think a little more broadly about that, most material science looks at the 85 stable elements, but maybe somebody else looks at the table of elements and says there's 253 flavors here that could be more subtly used. Maybe they build their materials world with 250 or so stable isotopes, whereas we're still back in the Bronze Age and only working with 85 elements. So,
Yeah. For that part, do you think, I'm just curious, in the material science, do you think, because I know some series that like maybe advanced technology from other location, or of course there's many possibilities, but do you think that you are fully aware what could be, maybe if we speak about security or intelligence, some advanced material from other places, like for example, to mention China, Russia, for example, here, you are not aware of, maybe?
no, I'm not aware of them, but I do. So Lou Elizondo and Chris Mellon, who are the people who brought those videos forward, uh, and who know most of what's going on, and another guy by the name of Eric Davis, are actually now good friends of mine, or I should say colleagues that I work with, and they and the others who are knowledgeable about what the current capabilities, at least of the United States, are, is they say we can't do this, and if China and Russia can do it, well, the whole world is in trouble, right? Because if they can move at this kind of way, that would basically negate the capabilities of any of the armed forces in the world. But then you also find out that they're studying this stuff too, because they're seeing it. And I don't think that they've come to any conclusions either about it. But in a way, and this is what, if anything, scares me, it's you're I think perhaps seeing the beginning of a new arms race, right? And this is an arms race to understand that the first who does understand this will have an advantage. I don't like that idea personally. I'm not that, I want whoever the good guys are, and I'm not saying who the good guys are, to get it first, right? But which is the other reason why I feel that having open access to this kind of information as much as we can will make sure that nobody has the upper hand. If we can get it open access, it will give the capability. Maybe someone in Nigeria figures it out first and they industrialize it first. Wouldn't that be great for Africa, right? To do this, wouldn't I don't think that one country in the world has the monopoly on figuring it out. So I feel though that the only way to get others around the world to perhaps not the three or four main military countries is to get as much of this information out in a safe way, in a credible way. And the beginning of getting that information out is to make it respectable to ask the questions, right? And then to give people data, hopefully, that they can figure it out. I mean, uh, proving that the data is real is the first thing to then get credible people to begin to ask the right questions about it and propose hypotheses.
So yes, we already speculate where it comes from, but if you can push more again, why it is designed in that way? If you can tell maybe the advantages or maybe limitation for the design, we don't know where it comes from. There's many possibilities, but why this design in particular? And do you think we can reverse engineer this design? This one of
Oh,
the
absolutely. No, I mean, that is the intent of what I'm interested in. If we can, so let's say, again, pure speculation, let's say that this so-called metamaterial is the one that with the layered bismuth magnesium um, stuff. Let's say that it is somehow involved with the propulsion. Okay, well, if it's part of the skin of the craft, or it's some layer of the craft that involves with the propulsion. Okay, and we know that it has the characteristics of a metamaterial. In other words, it's these thinly layered objects that you could pass a terahertz wave through that would cause some change in the gravitational constant, or perhaps it creates a I don't know, some sort of electromagnetic field that is repulsive. Okay, well, maybe we can make that. We don't have to rely on the small piece of it. How would we make that? And if we made that and then we put, we tested it with various kinds of terahertz waves or what have you, uh, what would it do? So, I mean, that's the beginning of reverse engineering. The other part of reverse engineering is just looking at the equations of what these things could, using our current understanding of physics, changing some of the assumptions uh, of Einstein's equations, which is what these physicists have done, and say, okay, well, if we make these assumptions rather than those assumptions, uh, okay, we can do this. How would we do it? And again, this is what the people who are doing and creating some of these, or trying to create some of these warp drives, are doing right now. They're saying, okay, how can we make it practical? And the reason why I talk about it in this way is that in my laboratory work, um, we ask a question and we say first, what is inevitable? Right? What is the kind of data that inevitably I require to answer this question? Because the current approach to collecting data is insufficient. So we say, this is the kind of data I want. Then we imagine let's say, a science fiction level instrument, a perfect instrument that could do it. We say, okay, well, we can't make that perfect instrument. And then we backtrack a few steps until we think about something practical that can accomplish this. And, we've created multiple instruments and sold companies that have started out of my lab in the many hundreds of millions of dollars. right? I mean, and then it becomes useful because we start with the impossible, and then we think backwards and we reverse engineer until we make it practical. And this is, I think, what we're going to be able to do with some of these objects and capabilities, is that we'll look at it and say, well, we don't know how to do it today, but here's what maybe we could do that could accomplish something close. And militaries do this all the time, right? They look at, so when the stealth bomber was made in the United States, Russia didn't have one. So they looked at what we could do and they said, okay, well, we're smart. We can figure this out. We can make it. And they've made them, right? So it's, you always look at what's possible. And once you know something's possible, it's actually almost inevitable that you will create it. I mean, that's just the way humans are. I mean, that's just the power of desire and the power of creativity that drives humans to the next step. It's kind of you know, being aware of what your neighbor can do, and you want to do it too.
I don't know. I want to ask you, to which level do you think this material is designed in intelligent way? Since you mentioned that the way we think about the material maybe is completely different what you try to see or seeking the truth. What is actually this? Where it come from? To which level the intelligence is designed when you think about it from human perspective? I don't know if you get my question, but since there's many speculation here, if you see this, why it's done like this way? Do you think this kind of in understanding something we don't understand, or intelligence? To which level do you think there's intelligence to come up with something like that?
Well, I mean, it's clearly something that has an understanding of physics that we don't, right? So this layered material. So, I mean, here's an example. A friend of mine who has worked in the CIA and actually ran a number of programs in the CIA. He was in what was called technology acquisition. That was his thing. That's a nice way of saying he stole stuff from the Russians and the Chinese. He designed the programs that would steal things. He said that they would sometimes acquire technology from Russia that they actually didn't understand, because the Russian physicists who had developed it started with different assumptions about things. Eventually, they were able to understand them, but it wasn't because the Russians got them from some other place. It's just because they had started creatively with a different set of assumptions about what something could do. And so, when you're talking about, let's say, an intelligence that is, let's again speculate, an intelligence that might be millions of years ahead of us, it has knowledge of how to manipulate the material world in ways that we don't. So the best we can hope is to emulate, and the best we can hope is to take it apart. Now, how would you do that? One of the instruments that we're building or trying to build in my lab is an atomic imaging scope, right? Something which actually sees the position of every atom. As it turns out, there's actually no instrument available today that does that. There are things called cryo-electron microscopy, which can maybe get close. Electron microscopy doesn't do it. There's crystallography, but crystallography requires things to be crystals, and so amorphous materials that have atoms more or less randomly placed, let's say, are not readable by this. So my position has been that if you want to understand some of these materials, you need the atomic position. You need an atomic atlas of what these things are, right? Now, at the same time as I'm developing that, let's say to do this, my primary interest in developing that thing is for my biology research, because it's one of those things that I said before is inevitable. Inevitably, we need to know the position of every atom in a cell if we really want to understand it, because form equals function, right? If you can understand the form of something, you can perhaps intuit the function. So, this instrument that we want to make has dual function. It can be used for this kind of materials analysis, any kind of forensic or actually research that might be going on in Silicon Valley. It could be used for metals analysis, or it could be used for the biology research that I want to do. So that, I think, is again an example of, you see something, you want to understand it, then you say, okay, well, what's the kind of data that I really need to understand what it is? I don't need to know necessarily what the elements or even the isotopes are. That's almost irrelevant. Knowing the position of those atoms in the material is what is important, right? Because that equals the function.
Mm-hmm. Mm-hmm. But I wanted to ask you what maybe other question still pondering in mind about this material, or maybe missing pieces in this picture between yourself that just like think about this material. What other questions do you think you want to answer, or maybe missing pieces in this
Hmm.
puzzle?
Well, there's several missing pieces. The first is, um, frankly, who made it, right? I mean, that's almost the most important thing, because who made it, in a way, leads you to ask the question, what's their agenda? What is the agenda? What's the goal? I mean, what is the goal of an object that can move like this, right? If the goal of the object could be understood, that might tell you something about the function of the object. The function of the object tells you a little bit about what the materials might be required to accomplish what it's doing, right? And then so you go down and down and down until you basically get to the atom. You go up and up and up, and you get these emergent properties of the material's capabilities and the goals of the object. I mean, the object itself doesn't have a goal necessarily, except who it was behind it that built it. And so, there's a whole panoply and a whole range of questions that are opened, including going all the way out to religious, right? And who's, if these things are real, what does that imply about our religious understandings? Um, and God, I don't even want to, pardon the phrase, I don't want to even get into that necessarily, because it opens a real Pandora's box of self-questioning about ourselves. So that, to me, is interesting as well. There's a very cultural and psychosocial, I think, at best, the realization that perhaps we aren't alone and something else has gotten here, uh, and is looking at us, is for us to realize that maybe we should band together in a better way, rather than fighting with each other, and realize that, not that we have to fight anybody out there. I mean, whatever they are clearly could wipe us out by just pushing an asteroid in our direction if they wanted to. What does that hopefully tell us about ourselves? That if anything, we can survive because something else did. We don't have to blow ourselves up. Something else got beyond that stage. That's a good thing, I think.
Yeah. And we also have a question from the audience asking about when the CI visited your office, and they want to know if there's this group of people was believer or just if there's a legitimate like something about UFO or maybe extraterrestrial life. I don't know if you can answer about this question.
Well, they didn't come to me saying these were extraterrestrials or that these were UFOs. They came saying, we have these uh, individuals who were harmed. We know, and everybody tells us, that you have made the best blood analysis systems currently used in the world. So, what can you tell us about their blood? Or what can your diagnostic instrumentation tell us about what happened to these people? Because again, it's like, okay, if they supposedly got close to something that was emitting an energy that hurt them, studying how they were hurt might tell you what the energy was, right? And if you understand what the energy is, that gives you two possibilities. Maybe you can protect yourself against the energy. At the very least, it tells you don't get close to these things, right? and here might be the range of distance that you can safely approach. But then secondly, again, it's like you asked before, it offers the opportunity for reverse engineering or to understand what these things are. So, I mean, that was as, I mean, I had looked at all of the medical files that were made available to me, and I was convinced that the data was real. What I didn't know was, again, what conclusion could I make? And just so the audience understands, uh, I'm not I'm not foolish. I don't believe everything that everybody brings to me. Everything that is shown to me first, I first ask the question, am I being fooled? Is somebody trying to trick me because they want to discredit this area, right? Or they want to discredit me. I don't think anybody really cares about me, but um, I think that uh, it's very important for scientists who get involved in this to always look at it with a wary eye, that just to make sure that you know the person bringing it to you, it isn't purposefully trying to fool you or hasn't been fooled themselves. They might think it's real, but they might be making a mistake. So it's this is the other reason, for instance, why I believe it's really important to go through the peer review process so that other people anonymously can look at what you're doing and can critique you to make sure that you're not fooling yourself, right? That you're, and then, you can publish something with as many caveats as you realize or you want. But if you look at any of my work in this area, we very, very carefully word things so that we don't come to conclusions. The newspapers who publish on the publications that we do think we made conclusions. I can't help that. But all I can do to continue to send the message is just that we're still just publishing data, and hopefully people believe that the data is real.
Mm-hmm. Since the close on end, I have a few questions, maybe related to the peer review, and I think also Eva Loeb was mentioning about the academic freedom. And I'm curious to ask you in this topic particularly why there is the academics maybe not really fully open-minded or dismissing that. And to be honest, some people really hate to talk about that. I'm curious why, when you say at the beginning, why you don't want to talk about this, why you dismiss this.
Well, I think it's been made fun of for so many years. There have been television shows that are silly, right? Ancient Aliens, as an example. I mean, it started with a decent premise that, were there aliens that visited in the past, but then it became silly, right? It became like a cartoon. And so it became easy to, make fun of people with that. I mean, for instance, I was asked by NBC News and the Today Show to do an interview with them a few weeks ago, and I finally decided no, I wasn't interested in that. Um, and I remember starting to write an email that I said, "Look, I'll agree to do this as long as you don't play X-Files music, throughout the thing." And then I said, no, forget it. I'm just going to say no. So there they are. They run the spot on NBC News, and the whole thing they play X-Files music. And Avi Loeb was actually on that briefly, and they played X-Files music right over him. I mean, it was just ridiculous. And so, you know, Avi, to his credit, just spoke right through it. Um, so I think there's people are afraid of being shamed, that they dare to think something. And I have been, you know, pat myself on the back. I've been successful in my career by knowing when I'm right and just doing it and not caring what other people tell me. If I know I'm right and I know I'm not doing unethical, and the question is reasonable, do it. And so I kind of don't care what other people think because I know I'm right. I know that sounds arrogant, but but that's the only way you progress, is by not letting other people shame you, because shame is a kind of societal control that other people use to get you to do what they want you to do rather than what you want to do. It's a control function. And so maybe I'm just was just built that way mentally, that I think that if you don't ask the question, it will never be answered. And so asking a question shouldn't be wrong, as long as you're not doing anything unethical, as long as you're not using resources you shouldn't be using, and as long as the goal is laudable. And if the goal is to understand our place in the universe, why shouldn't we do it? And if it's my time to do it, I I want to use my time, and as long as I have a lab of 30 people. As long as I'm still doing that, and I have 4 active companies, as long as I'm still helping them, why does it matter if I spend an hour with you and your readers and listeners talking about something which is fun and important? So I just don't care if other people are critiquing, because I mean now the people who are uh, who think we shouldn't be talking about it have been now proven wrong, because the government has come out and said this stuff is real. I mean, this is a historic event, to have the US government come out and openly say these things are real. We don't know what they are, but they're real. I mean, to me, I've had now a number of my science colleagues, my mainstream colleagues, including some that said, Gary, you shouldn't be doing this, write me emails and say, Gary, it looks like you might have been right. This is interesting. So minds are changing,
Mm-hmm. Yeah.
and that's a good thing.
Yeah. And what do you think, maybe final thought about other possibilities besides maybe understanding physics, or maybe how we can design such material like this? What are other possibilities do you think would help, even for you and Avi, to go? Maybe, as Avi said, he maybe could be wrong, for example, and for you, maybe it's something come from the engine, something we don't need in physics we can understand. What are other possibilities you think, just for people? Because some people said, why we should bother about that?
Why should we bother? Well, I mean, from a place in the universe perspective, it'd be nice to know that we're not alone. But um, from a just from a science advancement standpoint, again, to know that there is a level of physics beyond us that we can aspire to, I think that's important to know. To basically, if I get a hold of some of these materials that people have told me I will be able to help them study now, that they haven't been able to do anything before, using this atomic imaging scope that I want to build. Maybe we'll understand something about how you can put materials together to do things we don't know how to do today. That to me is a positive. Maybe there's an energy generation system here that could help, create energy more easily, right? Some of the people who study these things think that they're accessing the so-called zero-point field energy, that the only way that they could move from point A to point B with that level of speed is that they're basically reaching into the zero-point field and they're pulling out the energy from the zero-point field. That would be amazing. The other possibility is, though, if you make something like that and there's so much energy there, that could be a weapon. That's a bad thing. So, there's science always has that kind of give and take of possibilities. So, to me, I'm an optimist. I think at the end of the day, humans will do the right thing. We sometimes make mistakes, but to me, the opportunity to understand something more about the universe and to use technology in a more, useful manner to help humanity, that to me is what excites me. That's what gets me up every morning.
Mm-hmm. And that's and what makes you maybe fulfilled and satisfied.
Yeah, that if it the I don't expect, I'm 61 years old, so I don't expect in the next 20 years that we'll understand this, completely. I'll still be happy that I was able to play a part in making it possible for people to study this area credibly, and for others to contribute. I think others will make the big discoveries, and that to me, it's always about, I even look at my students. I look and hope and see potential in my students, and that is what I want to bring forward in my students, and that's what I want to bring forward here. I see potential here for humanity at large, and that to me is really what I think I'm working towards.
And finally, I don't know if you have any advice was given to you and it was a life-changing advice, or maybe through this decade, since you mentioned you do that you believe in and you seem to don't care about shaming or critiquing. But what advice was given to you and was a life-changing advice, if you remember?
So, I mean, I think the best advice is um, don't try to convince anybody of a conclusion, right? Know when you think something is real, and just get down and spend the time and do it and analyze it yourself to your own self satisfaction, and then publish it if you can, or work with others who can help you publish it, and go the conventional route. Don't try to convince your family members. Don't try to convince your friends. It's not about convincing them by discussion. It's about going the more traditional route, the tried and true, and don't come to conclusions, because all it takes is one disproof of your conclusion and you're wrong. I think we need, as a, let's say, your society, to form study groups, right, at a professional level, to say how can they contribute and what might be the advantage that comes to, the IAE, right, to understand this. I mean, already I think the aeronautics and aerospace community, which is like 50,000 people, they had a 4-hour uh, symposia on this subject. It was supposed to be 1 hour. It went for 4 hours. And they've formed a study group to basically say, and their interest in it was primarily because they say, okay, well, this might actually be a threat to aeronautics. If one of these things shows up and it causes us to divert and might cause a crash or something like that. So that was, that was the kind of real world consequence of it. But of course, behind that is, well, what are these things and how do they do it? So once you start getting professional organizations beginning to talk about this openly, and I am working with some other people to start to get some of the biology professional organizations to form around this. There's always safety in numbers, and so trying to do something individually is great, but once we can form organizations that will move this forward, again, the safety in numbers can give even me arguments that I don't know about, right? It's always about how you word things and how you position things. And so, there's white papers that need to be written on this subject. How do we talk to religions, right? This is not my specialty, but there are people who are already being brought in around this to talk about it. How do you talk to the various religions about this?
Yeah. I don't know if you have any final words, like say, any final words, like say, for the audience here.
The only thing I say is I'd like to thank the audience for keeping an open mind about this. And if anybody has any, any materials that they're aware of, let me know. And I'm more than happy to answer questions from individuals or help them whatever I can. I answer every email. It might take me a couple of weeks, but no email, no matter how crazy sounding it might be, goes unanswered.